The main focus of this lecture is how do you go about naming a covalent compound? Or can I call it covalent molecule? Do you remember the difference? A compound is two or more atoms chemically combined, either ionically or covalently. A molecule is a compound that is covalently combined, that is non-metal to non-metal. No ionic bonds per molecule, only the few, the proud, the covalent. So yes, we can call it naming covalent molecules. Remember polyatomic molecules? They are the covalently bonded groups of atoms. They are so common that they have been given special names that we use instead of the covalent naming scheme that we're going to learn in just a few slides. Fortunately, you will not be expected to memorize these. They will be provided for you whenever you need to use these polyatomic ions. Notice the ending has already been changed. When we had ionic compounds, you took the first name and then the second name you changed it from INE to IDE. Well, these have already been changed. It's chlorate, nitrate, hydroxide, carbonate. You do not need to change these endings again. It's important to learn the properties of covalent compounds, such as they have much lower melting and boiling points than ionic compounds. In other words, it doesn't take much to boil a covalent compound or to melt a covalent compound, whereas it takes a lot of energy to melt salt. Covalent compounds are often softer and then squishier than the similar ionic compounds. Think of it like this. Ionic compounds are like giant Lego structures. If you jump on a Lego structure, it feels hard because all the Legos are stuck very tightly to one another. Covalent compounds are more like those plastic ball pits that they have for little kids. While the balls themselves are held together very tightly, just like covalent molecules are held together tightly, the balls aren't stuck to each other. As a result, when you jump into the ball pit, you sink rather than bouncing off as you would if you tried to jump into a pit of Legos, and that would hurt too. You don't want to do that. So besides being softer and squishier, meaning the carbon monoxide bond is not stuck to another carbon monoxide bond, they are also much more flammable. They don't conduct electricity in water. If you could get them to dissolve in water, they aren't very soluble in water either. So these are just a few of common covalent properties. Now let's talk about naming. You're going to call me what? Yeah, I'm going to call you covalent. Don't forget, covalent is non-metal to non-metal. So we have a non-metal. Which one goes first? Well, the first word corresponds to the first element in the formula, which is the most metallic element. Now, I know these aren't metals. Look at your periodic table. So which one is more toward the metal area? So if we had carbon and if we had oxygen together, we would put carbon first. If we had nitrogen and fluorine together, then which one would come first? The one toward this end, the metal end, which would be nitrogen in the case for nitrogen and fluorine. Fluorine would come second. So the first word corresponds to the first element in the formula, the most metallic one. How about the second one? The second word corresponds to the second element in the formula with the IDE substituted at the end. It's the same as ionic here. For example, HF, you would say it as hydrogen fluoride. Notice I changed it from fluorine to fluoride. One thing of note is that you do not reduce for covalent compounds. Dinitrogen dioxide stays dinitrogen dioxide, N2O2. If that was ionic, of course we'd reduce it, but we do not reduce for covalent compounds. Consider N2O, NO, NO2, and N2O5. In many cases for covalent compounds, the two elements can combine in several different ways to make completely different compounds. And this cannot happen with ionic compounds except in the cases of metals that form more than one charge. For instance, carbon can share electrons with one oxygen to make carbon monoxide, or with two oxygens to make carbon dioxide. For this reason, it is necessary for covalent compounds to specify how many of each element is present within the compound. You attach prefixes to the element name to state how many atoms are present. Let's go ahead and try some. So we have N2O. How would you say that? Dinitrogen oxide. Wait, I just told you had to put a mono in front of that second one. Well, a note there is if there's only one atom in the first element, the mono prefix is dropped. But that's not the case here. It's in the second element. So why isn't it called dinitrogen monoxide? Well, chemistry has been around longer than they knew the exact chemistry for some of these compounds. Most of the old names have been phased out, thank goodness, by the International Union of Pure and Applied Chemistry, which was formed in 1921, so it hasn't been around all that long. So it's been phased out by their naming system. However, old names die hard, so you will occasionally see dinitrogen oxide instead of dinitrogen monoxide. Either one is fine. Everyone knows that oxide is monoxide, and now you do too. One other note, it is also called nitrous oxide or laughing gas. How about NO? Think about it a minute. Nitrogen oxide. Again, you could say nitrogen monoxide, but most people say nitrogen oxide. Well, how about this one? NO2. Nitrogen dioxide. You don't put the mono in front of it if it's the first element. You do put the di in front of it because there's two of it. N2O5. Look up your prefixes. By the way, make sure you write those prefixes down because you use them throughout covalence. Dinitrogen pentoxide. So let's practice a few. Sulfur and oxygen. Go ahead and pause and name this. Did you get sulfur dioxide? Why? You probably got sulfur monoxide or sulfur oxide. Why is it sulfur dioxide? Well, this is pointing out to you that you need to be told how many you have. You cannot assume they're balanced like you can for ionic. So you do need, somebody needs to say, well, how's the sharing happening? Because sharing could be happening, that oxygen is sharing, but this case it's not. It needs to have two oxygens to match the sulfur. There's no way you'd know that ahead of time. Let's try another one. In this case, I said 2 atoms of phosphorus and 5 atoms of oxygen. So what would the name be in this case? Let's go ahead and draw that right there. So phosphorus, you have 2 atoms, and this is how you draw. There's 2 atoms of phosphorus, and then you have oxygen, and then you have 5 of it. What would that name be? Diphosphorus pentoxide. Let's try another one. Please pause and think about how you would write that, the name. Carbon monoxide. Notice it's been changed to IDE. Let's try some more. Now you need to write the name given this chemical formula. Try the formulas. What I'd like you to do is I'm going to show you the name, and then you need to go and tell me what the formula is. Okay, let's try this one. Go ahead and pause. Bring up your periodic table and go ahead and write the formula for this. How many atoms? It doesn't say tri. So it's 1. You don't write 1. Okay, how about bromide? Make sure you keep this capital B. And how many of those? Try 3. Is that what you got? Go ahead and pause while you think about it. Okay, boron, B, I'm going to use hex. That's 6. That would be silicon. And it doesn't say try or buy, so you assume 1. Love that. Go ahead and stop and look at it. Hydrogen. It doesn't say how many numbers, so it's 1. That's iodine. Isn't that a good one? Ammonia. Ammonia! How do you get that one? Well, ammonia is NH3. Make sure you know that one. And then phosphorus triiodide. What's phosphorus? And iodine. We did that before. That's I. How many do we have? 3. Okay. I've had a lot of questions about crisscross in covalent compounds. To be happy, remember that's a state where it's trying to reach 8 in its outer shell. Compounds will grab, give up, or share electrons. The crisscross method assumes that the electrons are only used by one element at a time. No sharing is happening to form the neutral compound. Sorry, but since covalent molecules share electrons, you don't know if that electron is doing double duty or not. So you cannot use the crisscross method for covalent compounds. That's why the first thing you need to do is identify, is it covalent or is it ionic? I hope you've enjoyed this naming covalent molecules and that you've learned a bit. Please review as necessary. Enjoy.